Okay, this you're going to like because this is 5.7, 5.8, and 5.9 all together. So we're looking at characteristics of polynomial functions. So if we start with match each quadratic equation below to a graph, what characteristics did you use? And we'll talk through that as we go. So if I look, all of these are parabolas. This guy I recognize a parabola moved up 4 and it's right side up. Well, upside down, so one of these two, this is the only one moved up 4. There we go. Oh, number 1. Next easy one. This is upside down and moved up 4. Well, there we go. Next one, this is right side up, which means it has to be this one because it's the only one left. But this is super important here, and you'll use it a lot when we make equations. This tells us our x-intercepts, because if we let y equal 0, then x would be -1 and -2. That's why we used factoring and solved for those before. So I can see on this one, yes, I would have x-intercepts at -1 and -2. So this guy is number 4, which leaves this one being number 3, but let's look at the equation. I know it's upside down, vertical stretch of 3, and my vertex, how convenient right here. So I've got a vertex of right 1 and up 7, which when I look, right 1, up 7, yes. We are going to use a little acronym called FEAT. This is made up. Don't use this in university. Nobody will know what you're talking about. This stands for function, ends, which you can hardly read, intercepts, and turns. So just think it's quite a feat if you can scrappy graph a polynomial. So you're going to think of the function first, and we'll see how this works out in these examples just below. So if we have, this says f at x equals x cubed minus 3x squared. So let's just think f, e, I, and I'm going to leave a little bit of space, and you can hear Simba shaking in the background there, t. So f stands for function. I know it's a cubic. When I think of the cubic and I know it's right side up, that shape is going to look like that. So my ends are in quadrants 1 and 3. Intercepts. So I'm going to think about x-intercepts, and if they're easy, I will do them. I can factor out an x squared from here, so x minus 3, and then my x-intercepts would be 0 and another one, 2 zeros. This is called a multiplicity of 2, by the way, and 3 would be my other x-intercept. Y-intercept, I'm going to let x equal 0, so 0 cubed, take away 0 is just going to end up as 0. T stands for turns, and we will have a maximum, and you always say maximum, of 1 less than the degree, number of turns. So maximum of 2 turns. And now let's put this on the scrappy little graph, even though I already used part of the space to write in. So cubic, I know I've got to start here and here. X-intercepts, 2 at 0. That means it's going to touch and turn there, which means it'll form a parabola shape, either right side up or upside down. So I'm going to mark that with an X, so I remember that it's going to touch and turn at that point, and an x-intercept of 3, so it will cross straight through there. So if I'm going to start here somewhere, down I come, and then up, I need to touch and turn, and down. Ta-da! And good enough. That's all we need. Okay, next one. This guy, same thing, so F, E, I, and T. Function, I have a quartic. A right side up quartic is going to look like a W. So, like that, kind of. If it's upside down, I know it will look like an M, kind of like McDonald's, like that. So ends, I'm going to be quadrants 3 and 4. Intercepts, x-intercepts, not easy. X, not easy. Good enough. Y-intercept is easy. So let x equal 0, and I get 3. Number of turns, I have a maximum of 3 turns. So now let's put it on the scrappy graph. I've got starting and ending. X is not easy. Y-intercept of 3. Maximum of 3 turns. Okay, so I'm going to make an M shape and go kind of like that. Sure. I could have gone up higher, down lower, through here, and then back down. I could have gone way up high and then through here and back up and down. Lots of variations when that's the only information I have. Okay, other side of the page. Here's some great little rules. Polynomials with an even degree, x squared, x to the 4, and x to the 6, will have ends that go in the same direction, like your parabola. And by the way, just for interest, if you put y equals x to the 4 on your calculator just by itself without any x cubed, x squared, x whatever, you're going to end up with this shape, which looks like a parabola, which is why when we do the feet acronym on the other side, we say maximum number of turns, because this would have a maximum of 3 turns. It's not using all of those 3 turns because it has 0 as its root 4 times. So 0 with a multiplicity of 4 as the root. And I'll just show you that quick, because we would have y equals x times x times x times x, and then if you did your x-intercepts from there, if I let y equal 0, well, for this x, I'm going to have a 0, same for all the others. So I can either write 0 4 times, or I can write 0 with a multiplicity of 4. Polynomials with an odd degree, so x, x cubed, x to the 5, will have ends going in the opposite direction, like a straight line or a cubic, which you can hardly read on that page. Neither can I. So that means a cubic is going to cross like this, and remember we also said a cubic could be like this. So the more loopy one will have x cubed plus x squared plus x, or plus some other things or minus some other things. But our just basic cubic, y equals x cubed, is going to pass through a point, and it will have the curve similar to that. So not the really loopy curve. Match each graph with its equation. Justify your choices. So if I'm going to look, I've got a quintic here. That's a to the 5, quintic. And, well, let's look for that one. It would have a maximum of 4 turns. So 1, 2, 3, 4. There it is. Upside down, so ends are like the cubic function. This is right side up, so upside down, it would be in quadrants 2 and 4. Perfect. So this is number 1. Then let's look. Cubic. Oh, this is my only cubic function, which is this guy. And ends up, or not ends up, sorry, ends in 1 and 3. Then my quartic functions. So this is a right side up quartic. It should look like a W, and there it does. Which means this is my upside down quartic, which should kind of look like an M, which it does. The shape of these and the stretch and the elongation will depend on all of these factors. So you're not going to worry about that for now. You're just doing a super scrappy graph. So let's do example number 3 here. F at x equals x plus 1 in brackets to the 4 and x minus 2. So F, E, I, and T. Function, it's a quintic. And we're going to have, it's right side up, so our ends will be like our regular cubic function. Ends in quadrants 1 and 3. X-intercepts are easy. This will have an x-intercept of -1 4 times, or -1 with a multiplicity of 4 because it's a 2 to the 4. And we would have x equals 2. Y-intercepts, let x equal 0. So 0 plus 1 is going to be 1 to the 4 times 0 take away 2 will be -2. So 1 times -2 is going to be -2. Turns, I can have a maximum of 4 turns. Let's graph. So ends in 1 and 3, something like that. X-intercept -1, and this is hitting 4 times, so it will look like what we saw up above here when we talked about that on our calculator. So it's kind of going to look like the parabola, either right side up or upside down. We'll see what happens when we get there. So I'll mark that with an X. And then X-intercept of 2, so that's going to be 2. And now let's see. Oh, Y-intercept, I can put that on, -2 here. And down we go. So I could come through like this and turn up, and then I've got to touch and turn here, and back I go. Ta-da! So although it is a quintic, because of what happens with the x-intercepts, the graph ends up looking like a cubic. Totally fine. And that won't be perfect. You can put it on your calculator and see what it will actually look like. Okay, let's do this number 4. So function, we're going to have a quartic. So right side up is going to look like a W. It's upside down, so I'm expecting an M shape, which means I'm going to be in quadrants 3 and 4. Intercepts. X-intercept, easy. I've got -1 with a multiplicity of 3 and 3. So this means I'm going to cross the x-axis like the cubic function does. So it'll cross like this instead of with the more loopy crossings. And y-intercept. Let x equal 0, so -0 plus 1 is still 1 cubed. 0 take away 3. So 1 times -1 times -3 will be +3. So let's mark things on here. 3 for my x-intercept, and then y-intercept, or sorry, x-intercept of 1, -1 crossing like the cubic, I'm going to remember. So, starting and stopping there-ish. Let's give it a try. And then down we come, and crossing sort of like that. Not bad, kind of a weird shaped M, but good enough. Okay, super great.